A cold wind brushed across the quiet runway of Zhukovsky Airfield near Moscow. The year was 1976. On the concrete strip rested a strange, sharp-nosed craft, barely 10 meters long, its metallic skin dull under the winter sun. It looked too small to be an airplane, too heavy to be a glider, and too alien to be anything ordinary. Its name was MiG-105, though Soviet engineers jokingly called it Lapot, the old Russian word for a farmer's shoe. But this was no simple machine. It was the front line of a secret Soviet dream, a space plane that could take off, orbit Earth, return, and land on a runway like a fighter jet. It was the USSR's answer to the question that haunted both sides of the Cold War. Could man ever build a ship that flies in both air and space? The story of the MiG-105 began not in the 1970s, but a decade earlier, deep inside the design bureau of OKB-155, led by a brilliant engineer named Gleb Lozino-Lozinski. At the height of the space race, Soviet minds were already imagining what would come after rockets. Capsules could go up and come down, but they couldn't fly in space. They couldn't be reused. And for a nation obsessed with efficiency and military advantage, that was not enough. The Americans had their dinosaur concept, a winged orbital craft for reconnaissance and bombing runs. The Soviets watched closely, determined to match it with their own weapon of the future. And so was born Project Spiral, a code name for a reusable space system unlike anything the world had seen. The concept was breathtaking. A hypersonic carrier aircraft would haul a small orbital space plane high into the upper atmosphere. From there, the space plane would ignite its rocket booster, enter orbit, complete its mission, perhaps spy on American satellites or disable them, and then glide back through the atmosphere to land like a jet. It was to be half fighter, half spaceship, and entirely revolutionary. By 1965, detailed studies were underway. Designers drew up blueprints of the orbiter, compact, triangular, with a short wingspan and lifting body fuselage that produced lift by shape rather than wing size. Every line of the Lapot's body served a purpose: to survive the hellfire of re-entry without burning apart. Inside, there was room for one pilot, surrounded by panels of analog gauges, switches, and periscope windows. A thick, reinforced nose shield and heat-resistant tiles covered the body. It had no wheels, only retractable landing skids. Lighter, simpler, meant for a short, controlled touchdown. The aerodynamic form was tested relentlessly in wind tunnels. Models were dropped from aircraft and small gliders built for subscale testing. The data confirmed what Soviet engineers had hoped. The shape worked. It could glide, turn, and land, even after the brutal heat of spaceflight. In the late 1960s, construction began on the first full-scale prototype, the MiG-105-11. It wasn't built to go to space yet. It was meant to prove that the design could handle real-world flight. After years of delays, funding struggles, and secrecy, the strange metallic craft finally stood ready by the mid-1970s. At first glance, it looked primitive, but every inch was cutting edge. The nose could deflect airflow during descent. Its small delta wings provided lift at high angles. The cockpit was pressure-sealed with a unique ejection system, and the fuselage, short and wide, carried a heat shield meant to survive orbital return. On October 11th, 1976, the MiG-105 rolled down the runway at Zhukovsky. It accelerated fast, its engine roaring louder than its size suggested. For a brief, thrilling moment, the Lapot lifted off the ground and climbed into the sky. It wasn't an orbital flight, only a low-altitude test. But to the engineers watching, it was history. For the first time, a manned Soviet lifting body vehicle was airborne. Test pilot Alexei Fedotov kept the craft steady, gliding it for nearly 5 minutes before bringing it down to a rough but successful landing. The Lapot's skids slammed against the concrete, sparks flew, and the machine came to rest. The first flight was complete. Over the next 2 years, the MiG-105 flew several more times, each test refining its controls, glide stability, and landing profile. It never broke the sound barrier and never reached the edge of space, but it proved that the design was viable. What stopped it was not failure, but politics. By the late 1970s, the Soviet leadership had shifted its attention. The Americans had announced the space shuttle, a massive reusable orbiter capable of hauling cargo to orbit. Moscow wanted something comparable, not a compact space fighter, but a full-scale shuttle to match the U.S. That new priority became Buran, and once Buran received funding, Spiral was quietly buried. For the engineers who had spent a decade perfecting Lapot, it was a heartbreak. The program had survived secrecy, shortages, and skepticism, only to be overshadowed by politics. The MiG-105 never got its rocket booster, never flew to orbit, and never had the chance to prove itself in combat or exploration. Yet in failure, it left an invisible legacy. The lessons learned from Spiral carried directly into later Soviet and Russian programs. The BOR series, uncrewed test vehicles used through the 1980s, borrowed heavily from the Lapot's design, testing re-entry profiles and heat shield materials later used on Buran. The aerodynamic data guided future lifting body research, influencing the shapes of experimental aircraft and even modern reusable spacecraft. Even Western engineers studying Soviet archives after the Cold War were astonished at how advanced Spiral had been for its time. Had it been completed, it might have entered service years before the American shuttle. Imagine that alternate timeline, a Soviet space plane streaking through the atmosphere in 1978, carrying a pilot who could steer and land on a runway. Reconnaissance missions, satellite interception, perhaps even orbital repair flights before NASA ever launched Columbia. The MiG-105 could have rewritten the future of space travel. In technical terms, it was elegant. Its length was just over 10 meters, wingspan roughly 6.5, and takeoff weight near 10 tons. It had a maximum glide ratio of about 4.5 to 1, enough to reach a runway after re-entry from near space. Heat resistance came from advanced titanium alloys and ceramic panels. Every surface was designed to handle plasma temperatures that would melt most metals. The cockpit instrumentation was minimal. Altitude, attitude, speed, oxygen, and system pressure, all mechanical, no computers. Everything relied on the pilot's training and instinct. Fedotov later admitted the Lapot was tricky to control at low speeds, but stable and reliable once trimmed. To outside observers, it looked primitive. To engineers, it was a masterpiece of minimalism. But the Soviet space industry was never just about engineering. It was about competing visions. Korolev's legacy had pushed rockets and capsules. Simple, proven, mass-produced. Lozino-Lozinski's Spiral was the opposite. Complex, reusable, flexible. And in the rigid hierarchy of the 1970s Soviet system that made it vulnerable. Some military officials questioned its purpose. Why risk a manned orbital fighter when unmanned satellites could already photograph every base on Earth? Why spend money on an aircraft that could only carry one person when rockets could deliver entire payloads? In the bureaucratic balance of power, Spiral lost. By 1978, the MiG-105 was grounded, its last flight data recorded, its hangar lights switched off. The dream of a Soviet space plane faded into silence. Decades later, the surviving MiG-105 prototype was moved to the Central Air Force Museum in Monino, where it stands today. Dusty, faded but intact, a ghost of a future that never came true. Visitors often pass it without realizing what it represents. To most, it's just another Cold War oddity, but to those who know, it's a relic of a moment when human imagination tried to merge the sky and the stars. The Lapot wasn't just a machine, it was proof that the Soviet Union understood reusability long before it was fashionable. It was the ancestor of every winged space vehicle that came after, from Burn to Dream Chaser to SpaceX's lifting body designs. In many ways, Spiral was 50 years ahead of its time. When we look back now, the MiG-105 tells a quiet story about human ambition. It reminds us that not every great idea succeeds, and not every failure is wasted. Behind the rusted airframe in the old paint lies a vision that dared to defy gravity itself. It wasn't built for glory or publicity. It was built because someone believed that a spacecraft should fly like a plane. That reusability was the future, that one day humanity would step beyond rockets and glide through the stars. And in a way, that dream lives on. In every reusable vehicle flying today, in every engineer chasing efficiency, in every vision of space as a reachable frontier. The MiG-105 never left Earth, but its ideas did. Today, only a few black and white photos remain. The craft parked under the gray Moscow sky. The engineers standing beside it, bundled in coats, unaware that history was closing in. The blurred outlines of something that could have changed everything. If you ever visit Monino, find the Lapot. Look past the cracked paint and missing panels. You'll see the outline of a dream that reached for the edge of space and almost made it. In that silence, you'll understand what the MiG-105 truly was. A final echo of an age when the impossible still felt within reach.